Hello guys, welcome to Zip Code, and today we're looking into another type of code. We'll be talking circuit breaker pattern via Resilience4J to see how we can create fault tolerant and prevent cascading failures from integration APIs within your microservice. So without wasting any of your time, let's check that out. We're going to start as per usual. We're going to use our Spring initializer to define our project. So the project will be Maven based. The language will be Java. Spring Boot version 3.5.5. As I always advise, always take the latest stable version, in this instance 3.5.5, so that we get a long time support. And then the project metadata com.zip code. The artifact is Resilience microservice, and it is a demo project because this is for tutorial purposes. The packaging is jar, and our Java version is 17, so that should suffice. Then on the dependencies, we have dev tools for live reload when we actually make changes on our code base and we want that to reload without us manually restarting the server. Then we have Lombok for boilerplate in our POJOs. We also have Spring Web so that we create our REST APIs and we are able to make those calls or trigger some requests. Then we will be using Feign client to integrate to our external third-party API, and I will show you that API just now. And then lastly, we have our Resilience4J, which is why we are here. So we'll see this circuit breaker implementation as to how we can create some fault tolerance when it comes to calling the external API and it's unavailable or it's faulty. We can prevent that particular failure from cascading to our customers. So what we can do is generate that project. Then we're going to move over to our Finder and let's go to downloads. Where is my Finder so far? I'm going to take this project and put it into the actual project workspace. I'm going to go in there, and what I will do here is extract all of this into that particular folder. Now I'm going to jump over to my IntelliJ. So this is the API that we'll be testing with. So let me just open the other project that we just downloaded now. Let's jump to our workspace. Let's go to Resilience and open this guy. I'm gonna say new window so that we have it in its own window. So we have that project loading. Everything looks good. So let me just open this project quickly. First thing first, I'm going to rename the main class, the application to Java. I'm going to rename this to just application .java. So let's see. Okay, so is this thing done? Rename. Right. Okay, so this is done. Let's rename this quickly. Enter application.java should suffice and click OK. This will be sorted, and then here I'm also going to rename the application properties to application YAML because I prefer the YAML format of my application properties. That's why I'm doing that. And let's go in there. Firstly, let me just do server port. I'm going to expose this on port 8083. Then all these Spring configurations will be here. This is application name. And let me just do that quickly. Right. So that is what we have. Actually, I can leave this here. That should be fine. And in here, I'm going to quickly plug in the circuit breaker configurations. And just to go to our configurations, because there are a lot, let me quickly take them from here. And I'm going to put these at the Spring level. That is where they belong. And if you look here, there's a whole lot of configs that we need to set up. And you can see the cloud circuit breaker Resilience4J enabled. That is enabled true. And we have our circuit breaker configs, and we have default configs. all of these different configs. If you're interested in loading more or understanding what these each of these mean, just to highlight one or two here, the failure rate threshold is in percentage, which means if 50% of our API calls to the external service fail, then open the circuit so that you don't make further requests to that particular API until it's available and it's stable. So we also have a sliding window size and a sliding window type. So the sliding window type has a count base, and the count there's also a time base over here, so we can decide whether it's a count base or a time base, which in our instance we're using count, and we have 10 number of calls that can be made in the sliding window size. And we have the minimum number of calls that we can make, which is 10. And just to show you all of these definitions, if we come to resilience4j.readme.io docs circuit breaker, you can see they break each and every property down. Like I've highlighted, the failure rate threshold, this is percentage, which is 50, so it configures the failure threshold in percentage. When failure rate is equal or greater than the threshold, the circuit breaker transitions to open, and then it starts short-circuiting any calls to the APIs that we were calling. And there's all the other configs are also added here. The sliding window type, which is count based, that's what we're using. And you can see there's also a time based when the calls of the sliding window size seconds recorded and aggregated. So this will then start short-circuiting if any of these are actually met. So let's go to wait duration in open state. So if the circuit is open, what is the wait duration? And you can see you can set this as milliseconds, so you can add the value as milliseconds, and you can use that definition to say after this number of wait duration, retry the circuit and see if everything is working fine or something is off, right? And we also have all sorts of other configs over here, but what we have set on our default config should suffice. Just one point also to highlight is we can specify different instances for different API calls. So let's say in our instance, we are going to be hitting this backend API here, and you have, let's say you have multiple calls or different APIs that you want to trigger. You can define them here. So let's say maybe payment API, and you can continue to then define all of these for that particular instance and put those particular numbers. And then in your API call for payment API, you can then trigger those particular ones. But in this instance, we have one, so that should be fine. And then we have Open Feign circuit breaker enabled. We set that to true because we are using Open Feign in our instance, so we want to enable that for Open Feign. Then lastly, we have our management health circuit breaker enabled true, so that we're able to track what's happening in our circuit breaker. So with all of that being said, let's jump into the code. So quickly, I'm going to add a few packages here. So I'm going to add configuration package, and I'm going to add controller. I'm just going to do controller, and then we're going to add service, right? So I just want to keep this short and sweet, so I don't want to make it too complex. So over here, I'm going to start by defining my Feign client. So I'm going to have a Java interface for, I'm going to call it backend Feign client, just like that. So that should be fine. And then in here, I'm obviously going to have my Feign client like that. And I'm just going to say the name. This will be backend API. Then I do have a number of properties to set in here, but I'm just going to set what I need. The URL, we can actually pick this up from the application properties. So let me just do that quickly. I'm going to add an application property here, which will point to this backend API. So let's do that. I'm just going to go to the very end, and then I'm going to say zip code, external service, then I'm going to say backend API, and I'm going to say URL, right? And this will be HTTP localhost, and we have 8081. So this API will be running on 8081. So I've set the server port 8081 over there, and we'll be hitting this home controller. So you can see the request mapping is API v1. So if you go back there, we're gonna hit HTTP localhost 8081, and we have API v1, right? So that is the endpoint that will be hitting there. So we save this, go back to our Feign client quickly, and we just gonna set our Spring external service backend API. So for autocomplete, guys, I essentially just use control space, and then IntelliJ will suggest what I can do at that particular code block. So in this instance, it knows that I'm looking for a property, and I want to add that fallback property. And in my fallback, I need to define the fallback class. So let's add a fallback class quickly. So I'm just gonna add a new Java class here, and I'm gonna call it backend, let's say backend fallback. This is what I'm gonna call this class, and this will have Resilience4J for any logging, and it will just be a Spring component just like that. And this will implement our Feign client, our backend Feign client, right? So it implements that. Now we're gonna come back here, and we're gonna define the fallback, and our fallback will be what we just created now, backend fallback.class, right? Then now we are done with that. We're gonna define our endpoints. So in here we have all of these endpoints, but we're not gonna use all of them. So we'll just use the create and the read. That should suffice for this particular tutorial. So we're gonna do a post mapping just like that, and we are going to have we don't need to specify as public. We're gonna set this as response entity string, and what we're going to do is gonna call this create, because we are expecting a string, hence we're making this a response entity of string. We're not gonna pass anything in there because this API controller does not expect anything. But in your instance, you might have a request body that is expected, and you can pass that just the same as this. So if you're interested in seeing the Open Feign client, I'll attach the link in the description down below so that you can see that particular Feign implementation of how you can go about if you are new to Feign integration. So this should suffice for what we want. And we're also going to have our get mapping, and then I'm just going to do response entity of string, and this will be read. And again, we're not passing any parameter over here, and we are going to do that. Just one thing to highlight, the fallback implementation, if I use this one, I'm not going to be able to get the throwable, but if I do want the throwable of why the failure of my API calls, then I can use the fallback factory, and I can add a fallback factory class. But for this particular tutorial, I'm just going to implement it the simple way, and it should suffice for most use cases. But if you properly want to know and explicitly define the failures, then you can use the fallback class. If you're interested in that, please do let me know, and I will gladly add into this one as episode 2 or something like that, right? So now we're going to implement these methods that we just added now. We're going to implement them on our fallback so that we're able to track what happened there. So in our fallback, we're going to log an error, and we're going to say create API failed fallback triggered, right? So now we know that we've triggered the fallback just like so, and here we can return a default response, right? So this will be fallback default response. So what do I mean by default response? Say in this response string you are expecting a lookup, right? And if the call to backend API fails, you want to have default lookup values that get returned. So in our instance, we will just fix this to be a response entity. We're going to tell the API to say response entity dot OK or whatever the response is. If it's a create, you want to make sure that you respond with a created, or you want to have a no content response or something like that. But in our instance, we'll just use a OK, right? And then we're going to set the body like that. So in this body, you can set a default response based on your response entity that you want to have. So if you have like a, let's say var object equals to new object, and then whatever the object is, then you can set that object as the default response for that particular behavior. So when you hit the fallback, then you will properly handle a default response. Then we'll do the same over here. We will have our log. Let's just do log.error, and we'll say read API failed, and we will say response OK fallback default response. So I'm just going to say read fallback default response, then this will be create fallback response. Then we're going to save this. Now we have our Feign client. We've now wired our service into our backend API, so we'll be able to trigger those calls. So before we create our API controller here, that will then use, actually let me just create it. Let me go ahead and create it. So I'm going to call this resilience controller, just like so. And this will be a REST controller. And this will have a request mapping, right? And I'm just going to do API v1 resilient, just like so. Then in here, I need to auto-wire my business logic layer and trigger that API call and test my circuit breaker. So here's what we're going to do. We're going to add our business logic layer here. Our service being, it is advisable to use an interface, but to keep this short and sweet, I'm not going to use an interface. I'm just going to directly add this service implementation, just like so. But we would, a interface should be the correct implementation for that. So this will be a service class, and we're just gonna add some dependency injection here, and this will be of our Feign client. We're not using REST template, we are using our backend Feign client, just like so. Then we're gonna do that, and we are going to have our two API calls, and this will be string create, just like that. And in here, we're going to try, and we have a string response. Actually, we have a response entity, right? Response entity, response of create. So you see, response entity string response. I want to keep this short, so I'm going to call it response, and then backend Feign create. Then we're going to check if our response, right, dot get status. You can see that IntelliJ is suggesting what I want to check, and I do want to check a 200, which means any of the 200s, whether it's 200, 201, 204, I don't care. That should be regarded as a response. So then we will return the response.getBody. In our instance, it will be the body that is sent by this API, which is backend create successful, or the failure on our fallback, right? Otherwise, what we do here is we catch our exception E, and we log the error, and we will just log that exception as like that. Or if we want to be more custom, we will just say create failed, and we pass in that, and over here we just return a null, just like that. Save that, and again we do same for our read. Going to say string, and we're going to call this read, and we are then going to quickly do this. We do the same thing, and if this is a 200, return the body, and we catch our exception here, just like that, and we log our error, and we return the null, just like so. So you see that the power of IntelliJ, like I can quickly scaffold this code on the fly, and obviously it needs to make sense that this is the business logic that you want to do, and in our case, this should suffice. Then now we go to our controller, and in here we add our dependency. We're gonna auto wire our service class. So this will be resilience service impl, and this is what we're gonna call it. And then we're gonna expose two endpoints here because we are integrating to two endpoints, which is this create and read. We're gonna do the same here. I'm gonna say this will be our post mapping, and we make this public response entity. Let's just do response entity, just like that, and this will be of string, and I'll call this create, and then we're gonna do that, and we're gonna try and catch any of these, right? And we can return like a bad request, just like it's doing here. So our response entity can be bad request or internal server error or whatever the case might be. We can handle that. And in our instance, we can leave this as is, and we can go in here. Then we will say string response equals to resilient API.create. That is what we want. And we're going to return our response entity, right, .ok of the response, just like that. So you can see that we have our response, and we're going to set that response over there and respond to that. And similarly, we will do that for our get mapping, and we will do public response entity, and we have a string read, and we will wrap this safely in our response, and you can see that that auto-completes, and that auto-completes. Then we'll catch that exception, and we are going to return an internal server error, and we can just do respond to our clients just like that. So these are now done. We can safely start up this particular service and see how it behaves. So I'm gonna run this API and see if it's gonna start up and start working. Let me just remove this Lombok triggers. So the one thing that I want to see on the backend API, I'm not gonna start it up as yet because I want the request to fail so that you can see that the resilient microservice is going to trigger this particular response as long as backend API is not up and running. So our API is started. Let's quickly jump to our Postman. And in here, I want to add a blank collection. And that collection, I will just call it resilient microservice. Right, and in here I just want to add API. This API, let's just call it create, right? Then we will make this a post, and we have HTTP. This will be localhost 8083. If you remember, I exposed this via 8083 API v1 resilient, right? Let me just confirm that on our resilience controller, API v1 resilient. That is what we have. And there's no parameter that we are passing. There's no request body that we're passing. So no payload that we need to add there. We can just call that API. Add not found. What is the problem here? We have localhost 8083, and our service started in localhost 8083. Okay, let me just stop this and rerun it. Run that. So go back to our IntelliJ just to make sure there's no typos. Oh, we do have a typo here. Localhost, right? So our localhost is fine, and our service is up and running. So let's trigger this and see how it behaves. And voila. So create fallback default response, right? So which means our call to backend API failed, and our Feign client is able to trigger the fallback, which is this backend fallback, and it has the create fallback default response, just like so. And because now we have our create fallback, we can then safely say that the circuit is open. And if we trigger this again, the circuit will remain open for as long as our requests are failing. But soon as we start up that backend API, you will see that there will be a change in behavior. So let's go back to our IntelliJ, start up this API, the backend API. So now we are going to see this particular response coming through because once based on our configurations here in applications properties, let me just go there. Based on our configurations here, we do have wait duration in open state. We have 20 seconds. So after that, it then goes to half open. Then we can trigger. Once we trigger the API in half open state and request that to be successful, it will then be in a closed state, and then we can now safely call and consume that particular API. So let's trigger this again. And you see that it fails. Let me just see that this startup completed, this 8081, that is fine. So let's trigger this again. And again, we are not getting a response. So let me just make sure our OpenFeign client is pointing to the correct API. Let's go there. HTTP, a typo here again. What is happening with my local host? Local host. Okay, let me just restart this. Now we know that we had a typo here. And again, you can see that just because I had a typo here, it's also not able to hit this API, and it goes straight to the fallback because it can't make the API call to an unavailable service, right? So now we know that the service is up and it's running, everything is correct. We're gonna call this and we expect a success. So now it failed again. Let me just see. This service is up and running and it is on 8081. Again, our API localhost 8081 API v1. Let me just see in our home controller API v1. That is what we have. So what is the issue? Let me just see. Let me trigger this again. It's not going through. So let me just stop it and rerun it just to make sure that everything is refreshed, because we can see there is no typos anymore and everything looks good. Our URL is fine and our fallback is there. Right, so this has been restarted. Let me trigger this. And it's still failing. Why is it failing? Because we are calling everything. We do have our post mapping of create. What is the issue? And it does go to our, let me see, is this even up in the correct port? Or let me just stop that one and run it again, just to make sure that my IntelliJ is not stuck or frozen or something like that. Because this PC has tendencies of being slow. Right, so that is restarted. Now the service is up. We have our home controller pointing to API v1. Now let's go back, call this API, and we have failure again. Let me just see. Everything here looks fine. Backend API. Hold on. I did not enable Feign clients. Enable Feign clients. That's what I missed. Enable Feign clients. That's what I missed. And it keeps on going to the fallback because I missed Feign client. Oh God. All right, so now we're starting our application with the correct configurations enabled. Everything is looking good. We're pointing to the correct API. Let's make this one last time, and voila, we have our success. Well, I'm too excited. But let's see, why is that not going through? Boom, yes. Now we have our backend create successful because everything now is enabled and it's working as expected. So even though I was far ahead of the excitement, but you can see that we got our success. When we call it again, we get our success and we get our success. So if I go shut down this service, so I'm going to stop this service, and I'm going to go back and make the call again. And now you see it defaults back to the fallback mechanism. And if I go and start up the service again, I'm starting up the backend API and I go trigger this particular endpoint, and you will see that it fails because our open state is still not up. So I'm going to trigger it again, and now our open state was released and we have our backend create successful coming back. So you can see that our circuit breaker is working as intended. When the service is unavailable or the URI is incorrect or something is not working correctly for that integration call, it goes straight to the fallback, and it's able to service requests safely and much more cleanly for your consumers. So that is the end of this particular tutorial, guys. I hope this is helpful and you can use it in your organization, in your project, to safely handle and prevent cascading failures and have the best fault-tolerant APIs or microservice. For now, cheers.